So for our first example here, calculating degrees of freedom with two means, I went ahead and I gave you some data on my dog, Kobe, and on my best friend's dog, Mac. So having all this information here, we're going to go ahead and we're going to try and calculate the degrees of freedom we'd use if we ran a confidence interval or hypothesis test for this. And what we're going to start by doing is going ahead and listing the information. Now I want to be very clear again, it doesn't matter what we call sample 1 and sample 2. I'm going to call Kobe sample 1. A, because he's my furry little soulmate, but also because he has a higher average. And so when I subtracted these to run my hypothesis test or confidence interval, I'd get a positive. But seriously, he's amazing. So Kobe's going to be sample 1. And so what I'm going to do is I'm going to go ahead and list, I'm going to skip X bar because I don't care about that. I'm going to list S1, which is 5, and N1, which is 30. And the reason I'm leaving off X bar is because I don't care what it is here. I'm not using it. I'm only calculating degrees of freedom. Mac will be sample 2. S2 then will be 2. And N2 will be 25. So what I'm going to go ahead and do is I'm going to plug everything in here. I'm going to notice that I have 5 squared over 30 plus 2 squared over 25 all squared. Now, what I would do is if I'm plugging this into a calculator is I'd go ahead and find this value and write it on the side here. Next, I'm going to go ahead and find the bottom values. That is, I take S1, so square that, so that's 5 squared over 30, and I'd square that, and I would divide it by n minus 1, which is 30 minus 1. I'm going to add that to S2 squared, which is 2 squared over 25. Square that and divide it by N2 minus 1, which will be 25 minus 1. And I would find that value. Now, when you do this here, once again, I'm not dividing it yet. So I'd find this top value here, and then this bottom value here. And then, after I find those, I will divide them. Now, when I do this, I'm going to go ahead and I'm going to keep several decimal places. In fact, as many as possible here to make it as accurate as I can. So on the top here, I should get about 0.9, 8, 6, 7, and I'm going to get a whole bunch of 1s repeating. So I'll go ahead and I'll go down to the 6th decimal place. On your homework, this is about what I would expect. Now we'll do the same for the bottom here, and it's really important, one of the things to keep in mind here, is that if you are kind of having trouble with your calculator, simplify this as much as possible. So that is, maybe go ahead and write that as 29 and write that as 24. And when you go ahead and find this bottom number, then I'm guessing you get right around 0.0250. And once again, keeping 6 decimal places, we'll just go ahead and say 13. Now I want to be clear here that I did not round this bottom portion at all before I went ahead and added it. So that is, I kept all of this, and I plugged in on the same line plus all of that. So there was no rounding before I added those. Now I've got these two numbers, I'll go ahead and divide. And when you divide these two, keeping all those decimal places, I'm going to get right around 49. Now, the important thing to realize here is that I did in fact round this. And the reason I rounded this is because this is going to be my degrees of freedom measurement. And when I talk about degrees of freedom, I talk about whole numbers. Now, the thing to note is that because we're dealing with degrees of freedom here, we are always going to round down. So I had in this example 49.0169, and there's a bunch of decimal places there. So automatically I rounded it to 49. But even if you had 49.8, we would still round this to 49. So we will always round down when we find these degrees of freedom, and that is to ensure the highest level of accuracy we can have.